You go, man.
What else do you guys want to know about it?
Let's just take them on the back and show them all the fun stuff that it takes to actually run these machines.
There's some print samples over here on the table. There's two documents I want to point out at this point. This is a brochure. These are the two same documents, same media. Okay. The difference is one has a primer put on it prior to being put on your uncoated media. This one does not have the primer. You can see the color difference. Right. You guys, if you see anything on this table, you can go ahead and grab it, take a sample home. Every single time we start a print job, we print off this test pattern. And what we're looking for is what they call jet outs, a nozzle that gets clogged and it's not firing anymore. All right, right here there's a jet out. It's not firing. Once we see that on this document, within 10 prints, we'll compensate for it on the fly, either by increasing droplet size of neighboring nozzles or swapping out the color with a different color or combination of colors to hide it within the print. So the customers don't see a white line through the print. All they see is a nice print quality. Okay?
Fixes itself.
Fixes itself on the fly. It prints it up at the start of every job and every 100 sheets within the job. Okay? Couple test patterns here. Big difference in color. The difference, media. Not color grip or primer. This case, it's media.
Remember I told you guys that about how you can do that, especially with inkjet, right?
So it makes a big difference. Power cabinet, we have a lot of power coming in this machine because that power cabinet distributes power to all the components that you see here. Currently I'm running 208 on this particular machine and it runs 175 amps for everything being used here. Let's walk around to the back. There's three lines of 208 coming in. Once you guys are trained and your machine's installed in the field, this becomes your sleeping quarters.
Yep, that's
Not
where you
that
can
have
hide
to
and
do
take
a lot of
nap,
work. It's the
man.
toilet. It's just the biggest space available.
Plenty of space. Potty in it.
This is a fan unit. This has 4 large fan motors that create the vacuum to hold the media onto the drum. Takes moist air, pulls it away from the drum, and exhausts it out the top stack. Takes warm air from what they call a technical room and blows it onto the media to help aid in the drying. So 4 fans controlling all of that. Okay. Down on the bottom, you have a little small black motor. It's about this size. That's rotating your 500-pound drum. That little tiny itty bitty motor.
Freaking amazing, man.
That little motor is also used on the VarioPrint 6000 TTF units. Same motor, same part number.
Servo driven.
It's gear driven. There's a small transmission that's on it. It's a 3-phase 24-volt motor. Okay. Here's your maintenance module. This takes care of my print heads. So the print heads are staying here in a capped station. They're sitting above some liquid. They can stay in that capped station up to 4 weeks without drying out the nozzles. When we go to start a job, we purge ink through there, cleaning out the nozzle plates. These tissue cassettes go up and wipe the nozzles for us, cleaning off the extra ink that gets dripped out. Customers never touch the heads, and a lot of our competition, even some of our own products, it's mandatory the technician or the customer go in and manually wipe down the heads every so often. We don't do that on this machine. We use these wet tissue cassettes to take care of that wiping process for us. Thus, it saves the heads because customers like to use the wrong cleaning material, the wrong cleaning solution, and too hard of pressure, damaging $10,000 print heads. Here we do it all automatically. Seal around the door. This atmosphere in here is a controlled environment. 75 degrees Fahrenheit, 75% humidity. It controls its own printing atmosphere to get its perfect printing atmosphere for aqueous inks. It's water-based ink with pigment. Okay?
What is that? Print heads?
What's that?
The name of the print heads?
The name of the print heads? They're just, those are piezo electric print heads.
Crazy.
So there's a diaphragm that vibrates, pumping out your ink. Capable of dropping, each print head's capable of dropping 80 million droplets a second.
You guys hear that?
80 million droplets a second. That's how fast those diaphragms can vibrate and eject ink out.
That's crazy.
That's why that quality can be so damn good.
Can't even make sense of that in my head.
Right?
Here we have your conditioning module. There's a radiator in here. We also have water coming in that provides humidity for our environment in here. Temperature for this radiator is being controlled by a heater or chiller at the end of the unit. This is your server cabinet. Many different units in here. One takes and divides your jobs, your print jobs, into CMYK colors and sends in the information up to your print heads. This is going to work with an inline scanner that's looking at that bitmap for those nozzle outs. And if it sees one, it tells the first one what to do to fix it or compensate for it. This is a sheet height measuring system. One thing that wasn't mentioned, this tower that sits over here is 2 3-dimensional cameras that scan every single sheet being fed into this machine. If it's got a wave to it, a damaged edge or folded corner, that sheet is tagged and kicked out of the system. Why? Because we have a 1 millimeter print gap between media and the print heads. And if the media hits the print head, it could damage the print head. We don't want that, so we tag it and kick it out of the system. Log server logs up to 9 gigs of information a day about everything this machine does. What's the humidity inside? What's the paper path trajectory? What speed fans are rolling at? The only thing we're not watching is what data customers are putting on the media. That we don't care about that. We don't want to know everything else about it. You guys will use this if you come to the class. You'll use the information here to help troubleshoot the machine and to fix it when you're out in the field. You can also log into the machine through ORS, OSI Remote Services, and look at that data remotely. So before you even leave your house at 2 o'clock in the morning, you get an idea of what's going on with your machine before you even get there. Okay?
Yeah, that's the other thing. Our PPS people do work 24 hours.
Oh, sorry to scare you.
That's why I switched.
This is your service control station. You need a license to unlock it. It has the TSM on there. You use all your diagnostic programs through there, and ORS all are located here on this server. And the last one's the main node. Communicates with control boards throughout the entire machine. Okay?
And then the nice little tablet that's there is a wireless tablet that the technician can use as opposed to hooking up their laptop to all of this. They can either leave this hooked up or they can just disconnect that and walk around the machine anywhere they want to go and look at all the information from the service modes on that tablet as well.
We can run service tests on that tablet, so you don't have to start a test here and then run to the other side of the machine, and by the time you get there, the test is ended. You'll do it here off the tablet.
That's
These
cool.
are your ink containers. This is your large ink containers. On Rev 2 machines and 3 machines, they go to a smaller bottle. It's a 5-liter bottle. These are 10-liter bottles. So they've actually shortened the footprint up this much because they've combined it down to 5-liter bottles. So those newer machines have a smaller footprint. This is your workstation. All your service stuff is done here. Your Atom program, your TSM, SDS is all controlled here or by the tablet.
Incredible.
On the back side here, you can hear this bubbling going on. These backpacks are monitoring the humidity inside the paper tray modules. If there's not enough humidity inside the paper tray modules, we pump compressed air into these water bottles, causes the water to bubble, collects moisture, and it brings the humidity up to around between 35 and 40% humidity, which is the perfect storage environment for media. This keeps media flat, keeps it straight. What happens out in the field when you get in areas that are too much moisture? What happens to your media?
Crinkles up.
It's crinkles, gets wave to it. If the humidity is too high, we push compressed air, which is dry, straight into the paper tray modules, lowering the humidity down to 40%. So depending upon where you're at, your water bottles may be bubbling or it may not be bubbling. Okay? And that's only on this product. No other product has it through the Canon line.
It's a great idea too.
Oh yeah.
So nice because as I was explaining to you guys earlier, the media is one of the more important things that we have to concern ourselves with
Right.
all of these customers out there. You will find that out. You will find that out.